Alright, I'm going to focus this video on finding limits using a table because it's a fairly computational thing and not something that's super difficult, and it's also not something we use all that often. But at least in these two examples, we'll see examples of sort of the good and the bad sides of calculating a limit using a table. So the idea is that we start with our function, which in this case is x to the 6th minus 1 over x to the 10th minus 1, and we create a table of values. We're going to take x values, and then we're also going to get values back for x to the 6th minus 1 divided by x to the 10th minus 1. So the first thing we want to do is plug in these values for the different things. So we're going to plug in a couple of numbers slightly bigger than 1, so maybe 1.001, 1.01, and 1.1. So I kind of like to draw a little line here and tell myself, well, this is kind of where 1 is. And then I'll put a few numbers that are slightly smaller than 1, 0.999, 0.99, and 0.9. And I'm going to find the values, the y values, this function value, for each of these 6 values, but not at 1, because remember a limit, we don't evaluate it at 1, we evaluate it at numbers near 1. So that's why I'm not actually going to plug in 1, I'm just going to plug in numbers near 1. So I can start with maybe the 1.1. So really all I'm doing is taking 1.1, raising it to the 6, subtracting 1, and dividing it by 1.1 to the 10th minus 1. If you punch that into a calculator, you'll get 0.48412, I believe. So that's the bottom number. Next, you'll want to plug in 1.01 and do the same thing. So then this would become 1.01, this would become 1.01, and then your new number is 0.58802. So that would go here, 0.58802. And you keep doing that all the way up, so the next number is going to be 0.6012. You plug in 0.999, and it looks like, oh, sorry, that one's not 6012. It looks like 1.001 is 0.5988. 0.999 is 0.6012. Right above that is 0.61202, and the 0.9 is 0.719397. And then your goal is supposed to be to figure out what number would be right here. So as we look at this, the numbers going this way are getting close to something, and the numbers coming this way are getting close to something. And to me, in my mind, it looks like they're getting really close to 0.6. So that's a way we could figure out the limit, is just by putting some numbers slightly smaller, some numbers slightly bigger on each side of the number that we're trying to evaluate. We're trying to find the limit as x approaches 1. And then make sure you list them in the right order, so getting closer and closer to 1 this side, and getting closer, so I guess further and further away from 1 on the other side. Plug in your values into your function, evaluate, and check from top to bottom, see what they're getting close to. And in this case, it's 0.6, so the limit exists, and we have a value. So we can do a similar thing with a problem like limit as x approaches 0 of sine of pi over x. And maybe you choose your x values to be something on either side of 0, right? So we have a 0 down here. So let's say we choose negative 0.1 and negative 0.01. I'm running out of space, but you could choose like 0.001. And then on the other side, you could do like 0.1 and 0.1, 0.01 and 0.1. So positive and negatives, right, are the either side of 0. And we're going to plug these into sine of pi over x. And so if you think about this, this is sine of pi over negative 0.1. And that would be the same as sine of pi over negative 1 over 10. And if you simplify that, that's really sine of negative 10 pi. And if you remember, sine of negative 10 pi on the unit circle is really going to be 0, because you're at sort of one of those spaces on the unit circle where sine is 0. So this is going to be 0. This is also going to be 0, the second one, because it's just sine of negative 100 pi, so it's 0. And this is positive, and this is positive. So these are all going to be 0, right, because they're all just going to be sine of 10 pi, sine of 100 pi, sine of negative 100 pi, sine of 10 pi. So you would just be like, well, so my answer is the limit as x approaches 0 of sine of pi over x is equal to 0. Yay, I'm done. But it turns out that that is actually not the correct answer, and your table here is actually misleading. So if you were to actually graph this function, and I'm going to have a hard time probably drawing it here, but this is 1 and this is -1. What happens is it's going along like it normally would, like a sine function, but right here next to 0 it gets crazy, and it goes like this, and then it kind of goes back to normal. So there's actually, if you try to zoom in on this and figure out what value is right there, you're actually never going to be able to get a value. It oscillates so fast up and down right around 0 that there's actually not a limit value. So the actual answer here is does not exist, but you can't tell that by the values you chose for your table. So tables are somewhat dangerous, and I'll make a quick statement about that at the end of this video. So here's the sort of moral of the story, or the conclusion. Although using a table is one way of estimating limits, it's not always going to give us the correct answer. So what we'll do in class on Friday is look at some other methods that are sort of better techniques of actually finding limits. So just recall that sometimes a table is good, and if you can get the answer, that's great. But you always want to be really careful because you don't know if the numbers that you chose might be giving you a misleading answer. So in the example we saw with sine of pi over x, we happen to just choose numbers that happen to have all the same values. But that's not always going to be the case. So just be careful when you're using tables and trying to calculate limits.